for example, find the distance between the points P32 and Q -2 -3. Solution. What are the points here? Points given here are P32 and Q -2 -3. Okay. Now we shall take our x1, y1 and this as your x2, y2. Or you can take this as your x2, y2 also and this as your x1, y1 also. Any way you want. Okay. So let us consider the first coordinate as x1, y1 and the second coordinate as x2, y2. That is P coordinates as x1, y1 and Q coordinates as x2, y2. So therefore, the distance PQ will be root over of x2 minus x1 square plus y2 minus y1 square. And I told you that you can write this formula in this manner also. x1 minus x2 whole square plus y1 minus y2 whole square. Whether you write y2 minus y1 or y1 minus y2, it's the same thing. Okay, because there's a whole square, this is a perfect square here. So you can write it any way you want. Okay, so now let us put the values here. Root over of x1 minus x2. What is x1 here? Let us write the points here.
3.
Here x1 is 3, y1 is 2, x2 is -2 and y2 is -3. Now we'll work with the signs. Okay, remember, do not make sign mistakes. Therefore PQ, distance PQ is root over of x1 minus x2. So x1 is 3 minus x2. x2 is -2. So see that I've written it with the sign. I've written x2 with the sign. x1 minus x2 whole square plus y1 minus again y2 with the sign whole square. So this becomes root over of 3 plus 2 whole square plus 2 plus 3 whole square. So this becomes root over of 5 square plus 5 square, which is root over of 25 plus 25. You cannot remove the radical because you have a plus sign here. Okay. If you had a multiplication sign, then you could have removed the radical. So this becomes root over of 50. And this is a pure surd. You can write it as a mixed surd. Root 50, you can write this as root over of, if you prime factorize, this is 2 into 5 into 5, which is root over of 2 into 5 square, which is root 2 into root 5 square. And 5 square root of 5 square is 5. So this becomes simply 5 root 2 units. This is the distance between P and Q. And this is how you use distance formula to find out distances. Now, once through with the examples, we start with the first problem, exercise 19.4. Problem number 2. See this problem number 2 here. If you have your textbook, read it from there. If you can't read it from here, you just try to make it a little bigger so that it is visible. A little more visible. Okay, now you can read, I think. Question number 2. A is a point on the y-axis whose ordinate is 4 and B is a point on the x-axis whose abscissa is -3. What do you mean by ordinate and abscissa? If you remember, I had told you the definitions of ordinate and abscissa. What do you mean
So
by
the
ordinate
value
and
of
abscissa?
x,
Coordinate.
so the value
Sir,
of x is
ordinate
abscissa
is
and the
y
value of
and
y
Wait,
is
abscissa
ordinate.
is
ordinate.
y.
Coordinate is yes, sir.
Yes, Sonam, tell me.
So the value of x is abscissa and a value of y is ordinate.
Yes, the value of the x coordinate is called the abscissa and the value of the y coordinate is called the ordinate. Okay. If you see in this question, it is given that A is a point on the y-axis. So if you remember, when we were plotting graphs, any point on the y-axis, what was it like? If you remember, any point on the x-axis, what was the special about any point on the x-axis or any point on the y-axis?
So the value of y is 0.
Abscissa
So
or
if the
ordinate will
point
be
is on
0.
x-axis,
Any point on the x-axis that you take, any point, whether you
Their
take this
y
point or
ordinate
this
will be 0.
point,
the ordinate is 0.
any point, the ordinate will be 0. Any point that you
Yes, sir.
take. Okay. And any point on the y-axis that you take, any point,
Abscissa will be
the abscissa will be 0. So 0 comma something. And this also will be 0 comma something. Okay. So now again in the light of this, if you read this, A is a point on the y-axis. Let us say A is this point. Not here. A is a point on the y-axis. So not this point. So A is a point. Let's say this is the point. A is a point on the y-axis whose ordinate is 4. So clearly the abscissa of this point is 0. Ordinate is 4. So this is your point, right? And B is a point on the x-axis whose ordinate is -3. B is a point on the x-axis. Let us say this is the point whose abscissa is given to be -3. That means this is your -3. So what are the points? These two are your points. So let the points be, I start by saying, let the points be let the points be A 04 and B -30. The question is find the length of the line segment AB. That means the length of line segment AB means you have to find out this distance. This distance you have to find out. Okay. So you know the x coordinate and the coordinate of A, you know the coordinate of B. Apply your distance formula. Therefore, AB is equal to root over of x2 minus x1 whole square plus y2 minus y1 whole square. Take this as your x1 y1 and this as your x2 y2. Put in the formula. X2 is -3, x1 is 0 plus y2 is 0 and y1 is 4. That's it. So this is root over of -3 square plus -4 square, which is root over of 9 plus 16, which is square root 25, which is 5 units. This is the distance between A and B. I have used distance formula to calculate this distance. Now you can use normal way also. Even if you don't want to use, this was a very easy problem. See how much is this distance? This distance is 4 units, right? How much is this distance? This distance is 3 units. And this is the right angle triangle. You can use Pythagoras theorem to find this out to be root over of 4 square plus 3 square simply equal to 5 units. Understood? Especially for this problem. Instead, if you don't want to use distance formula, you can use it this way also. Any questions? Let us see the next one, number 5. number 5. Now if you read question number 5, the question states find the point on the x-axis which is equidistant from the points 2 minus 5 and minus 2 9. So suppose you have your x-axis like this here. Okay, let us say this is your x-axis. I'm not drawing the y-axis because you don't need the y-axis. Let us say this is your x-axis, and there's a point here on the x-axis. Suppose I call the point this to be A. Okay, I call this point to be A. So question is find the point on the x-axis. I need to find out the coordinates of A, which is equidistant from the points 2 minus 5. Let us say your 2 minus 5 is a point, say over here. Let us call this point P, 2 minus 5. And another point is minus 2 9. Let us say minus 2 9 is say somewhere over here. Let's say let's call this point Q. Okay, let me draw it a little that side so that does not look on a straight line. Let us suppose the point Q is here, and the coordinates of this is given to be minus 2 9. And you will have, and what is the condition given here? The condition that is given here that A is equidistant from P and Q. What do you mean by equidistant? At an equal distance. That means distance of A and P must be equal to the distance between A and Q. Okay, so that means these two distances must be equal. That is what they mean. The coordinates of A must be such that AP must be equal to AQ. Now, since A is a point on the x-axis, I start by saying let the coordinates of A be x1 comma 0. You can take x comma 0 also, no problem. Okay, let the coordinates of A be x1 comma 0. Why have I taken this? Because I know A is a point on the x-axis, therefore the y coordinate has to be 0. So let us first find out the distance AP. Therefore, what is the distance AP? Let us write down the coordinates first. So here A is, so that there is no confusion, let us write down the coordinates. Here A has coordinates x1 comma 0 and P has coordinates 2 comma minus 5. Let us calculate the distance. Therefore, what is AP? Distance AP is equal to root over of, okay, let us take this as your x1, y1, x2, y2. Okay, so this is root over of x2 minus x1 whole square plus y2 minus y1 whole square, which is equal to root over of, now just put the values. X2 here is 2 and x1 here is x1, and I don't know, I have to find out, plus y2 here is minus 5 and y1 here is root over of 2 minus x1 square plus minus 5 square, which is equal to root over of 2 minus x1 square plus 25. This is the distance AP. Okay, now we want to calculate the distance. We have calculated this distance AP. This distance we have calculated. Now we want to calculate this distance AQ. So let us write down the coordinates first. So here A is x1 0 and Q here is minus 2 9. Okay, so now consider this as your x1, y1, this as your x2, this as your y2. Okay, so therefore, what is the distance AQ? Is root over of x2 minus x1 whole square plus y2 minus y1 whole square equal to root over of x2 minus x1 x2 here is minus 2, x1 is x1, we want to find out, plus y2 minus y1, y2 here is 9 and y1 here is 0. So this is root over of minus 2 minus x1 square plus 9 square is 81. We have calculated distance AQ. So now what is here? What is given here? The distance AP and AQ are equal. So therefore we'll use that condition. According to the problem, AP is equal to AQ. Just put the distance AP. What is the distance AP? Root over of 2 minus x1 whole square plus 25. This is what we had calculated AP to be. And AQ just above we have calculated this to be minus 2 minus x1 whole square plus 81. Okay, that is what. Now we need to solve this equation. So first of all, we need to remove the radical. So we square both sides. Root over of 2 minus x1 whole square plus 25 square both sides so that the first radical gets removed. That means you're only left with 2 minus x1 square plus 25 is equal to minus 2 minus x1 square plus 81. Now you expand by a minus b whole square formula or a plus b whole square formula, whatever. You expand on the left hand side and the right hand side. But before expansion, what I would like to show you here is a very important step. 2 minus x1 whole square, you write it as it is, plus 25. Now see here, I have a minus 2 minus x1 here. In this case, what we can do here is, I can take a curly bracket, I can take minus 2 minus out, and I can write this as 2 plus x1 whole square plus 81. This is a very important step. You can expand here also, no problem. I'm not saying that you cannot expand here. You can expand at this step also. I don't have any problem. But this is a step that I am showing because those of you who want to take up mathematics later on, this step will come very frequently. So now what happens is that 2 minus x1 whole square plus 25. And because there is a minus sign and minus sign has been raised to an even power here, this minus becomes plus. So this is simply, see that minus 2 minus x1 has simply been written as 2 plus x1 whole square. That is the beauty of it. Because I was able to do this because I saw that minus has been raised to an even power. That is why I was able to do this. Now we can expand comfortably and solve this. Expand this by a minus b whole square. So this is your a square plus b square minus 2ab plus 25. You have a square plus b square plus 2ab. Okay. So now this is 4 plus x1 square minus 4x1 plus 25 is equal to 4 plus x1 square plus 4x1 plus 81. Now what happens in the next step? This 4 and this 4 cancels. X1 square and x1 square also cancels. You're only left with 4x1 minus 4x1 this side and plus 4x1 that side. Okay, so you take everything to one, x1's on one side, so minus 4x1 is equal to 81 minus 25. So this is minus 8x1. And how much is 81 minus 25? 56. So this is x1 is 56 by minus 8. which is minus 7. So we have solved for x1 and found out the value of x1 to be minus 7. So therefore, what is the coordinates of A? We have taken the coordinates of A to be what here? We have taken the coordinates of A to be x1 comma 0. And we have used AP is equal to AQ, this, to find out the value of x1 as minus 7. So therefore, the coordinates of A is minus 7, 0. That's it. So A is the point minus 7, 0, which is always the equidistant from the points P and Q, whose coordinates are given to you. Okay. Let us do the next problem now. Number 9. If you have any problems of your own, you can ask. Any problem in between that I'm skipping. If you have anything to ask, you can ask. Okay. So number 9. If you read question number 9, question number 9 states the x coordinate of a point is twice its y coordinate. A particular point is there such that its x coordinate is twice its y coordinate. Okay, so whatever the y coordinate is, you multiply that by 2, you'll get the x coordinate. Next sentence is if P is equidistant from the points Q and R, find the coordinates of P. So let's see, what are the points? Let's say P is a point here. Okay, I don't know the coordinates. I'll see. And let's say there are 2 points, Q and R. So let's say Q. What are the coordinates of Q given? 2, minus 5. And the coordinates of R, say here, is given to be minus 3, 6. Now these 2 points are such that this distance PQ is the same as this distance PR. These 2 distances must be equal. And the point P is such that in the first sentence, it is given the x coordinate is twice its y coordinate. So I say, let the y coordinate of P be, let the y coordinate of P be, say, y1. That means let's say that the y coordinate is y1. Let us say. You can take y also, no problem. Let us take the y coordinate as y1. Therefore, what is the x coordinate of P? X coordinate of P. The x coordinate of P is twice the y coordinate. Therefore, the x coordinate is twice of the y coordinate, twice of y1. That means the x coordinate is 2 y1. Okay, so the coordinates of this point is 2 y1 comma y1. And Q and R are 2 points such that PQ is equal to PR. That is, P is equidistant from Q and R. Okay, so what are the question is, what are find the coordinates of P? So once we have done this, let us find out the distances. Here, what is P? P here is 2y1 comma y1. And what is Q? 2 comma minus 5. Okay, so let us take this as x1, y1, x2, y2. So what is the distance PQ? Root over of x2 minus x1 whole square plus y2 minus y1 whole square, which is equal to root over of, put the values, x2 here is 2 and x1 here is 2y1. So 2 minus 2y1 whole square. Okay, plus y2 here is minus 5. Y2 here is minus 5. Minus 5. And y1 here is y1. Okay, this is your y1. So this is what your distance PQ is. Now we have proceed to find out the distance PR. Coordinates of P is 2y1 comma y1, and what are the coordinates of R? The coordinates of R are given to be minus 3, 6. Therefore, PR again is root over of x2 minus x1 whole square plus y2 minus y1 whole square. Again, take this as x1 y1, take this as x2 y2, and put it in the distance formula. You get root over of x2 minus x1 whole square plus y2 minus y1 whole square. That's it. We have found out the distances PQ and PR. Now, according to a problem, P is equidistant from Q and R. So, therefore, PQ must be equal to PR. So, therefore, now put the values of PQ and PR. PQ here is 2 root over of 2 minus 2y1 whole square plus minus 5 minus y1 whole square is equal to, and PR we have calculated this to be minus 3 minus 2y1 whole square plus 6 minus y1. Square both sides just as we had did in the last problem, squaring both sides. We get radical is removed, so you simply get 2 minus 2y1 whole square plus minus 5 minus y1 whole square is equal to minus 3 minus 2 y1 square plus 6 minus y1 square. Now we shall solve for y1 here. Let's see what comes. Now there are certain things to realize here once again, just as I had told you in the last problem. Twice of 2 minus y1. This can be written as twice of 1 minus y1 whole square. Plus again here I have minus 5 minus y1. So I can write this as minus of 5 plus y1 whole square. Again I have minus 3 plus 2 y1 whole square plus, and you have 6 minus y1 square. Okay. So now here what this becomes? This becomes 2 square into 1 minus y1 square plus, again minus has been raised to an even power here. That means this minus becomes a plus. So this means 5 plus y1 square. Again minus has been raised to an even power here. So this becomes 3 plus 2y1 square plus 6 minus y1 square. So that means this becomes 4 times, and you expand this by a minus b whole square formula. A square plus b square minus 2ab plus again this by a plus b whole square formula. So this becomes a square plus b square plus 2ab. 2 into 5 into y1 means 10y1 is equal to, again this is a square plus b square plus 2 into 3 into 2y1 plus 6 square plus y1 square minus 2 into 6 into y1. That's it. So now let us see what we get. We have 4 plus 4 y1 square minus 8 y1 plus 25 plus y1 square plus 10 y1 is equal to 9 plus 4 y1 square plus 12 y1 plus 36 plus y1 square minus 12y1. That's it. Take all the y1 squares together, take all the y1s together, take all the constants together. You have y1 square here and you have a y1 square here. So this you get 5y1 square. Next you have a y1 here and you have a y1 here. Okay. So minus 10 plus 4, plus 10 plus 4 will give you a 14y1. Okay. And 4 you have here and you have a plus 25 here. So that makes it 29 is equal to, again here same thing, y1 square y1 square. That makes it 5y1 square. Again y1, what do you have? You have a plus 12 minus 12. This cancels off. That's finished. And you have plus 9 and you have a plus 36. So 36 plus 9 will give you a 45. So again 5y1 square cancels from both sides. So what are you left with? Simply 14y1 is plus 29 is equal to 45. That means you can write this as 14y1 is equal to 45 minus 29. That means 14y1 is equal to, this will give you a 16. Okay, this will give you a 16. Y1 is equal to 16 by 14. 7. 8 by 7. Now the process remains the same. We are getting a very strange point here. Y1 is equal to 8 by 7. If I have not made any plus or minus mistake here, I'll just go over once again and I'll let you know tomorrow if I have made any mistake. But we are getting a point like 8 by 7. So what should be the coordinates of P? Therefore, coordinates of P was what? Coordinate of P was 2y1 comma y1. 2y1 comma y1 equal to P. So this will be twice of y1 comma y1. So this is P 16 by 7 comma 8 by 7. Okay, so that is your required point. Okay, so unless